Before beginning this section, make sure that you review the Introduction to Hypothesis Testing About Means section. In this section, we will discuss hypothesis tests about means when the population standard deviation is known. First, recall the three sets of hypotheses, test statistics, and rejection rules that we discussed in the Introduction to Hypothesis Testing About Means section. In this section, we will discuss a variety of hypothesis testing examples about means. First, there's an additional measure in the previous slide that we have not discussed thus far. If we go back to this slide, all of these measures we should be familiar with, except the Z alpha measure. Here we have steps for computing Z alpha. By definition, we define Z alpha as the Z-score with the upper tail area of alpha. Step 1 for computing Z alpha. In step 1, we must determine the area that we're going to look up on our standard normal cumulative table. That area is defined as 1 minus alpha. In step 2, we go to the area section of the standard normal table and find the area as close as possible to the area we computed in 1. This area is our Z alpha value. Again, we have our steps for computing Z alpha over 2. We have completed these steps in a number of sections previously discussed. Also, recall our steps for hypothesis testing. We will repeat all of these steps for all of the examples on hypothesis testing that we will complete. Example 1, revisited. In this example, we collected a sample of n equals 40 EMS calls and computed an average response time of 13.25 minutes, and the population standard deviation sigma was equal to 3.2 minutes. Set up hypothesis tests in order to find evidence to prove that they are not meeting their goal. Recall for this example, their goal was to respond to calls in 12 minutes or less. Since we are trying to prove a claim, we should state this claim as our alternative hypothesis. In this case, our alternative hypothesis, the claim that we are trying to prove, is that the EMS system is not meeting their response goal. Our null hypothesis, therefore, which we should always place on top of our alternative hypothesis, is that the EMS system is meeting their response goal. After stating these hypotheses in words, we should state them using their corresponding statistical measures. For this problem, our null hypothesis is that the population mean response time is less than 12 minutes, and our alternative hypothesis is that the population mean response time exceeds 12 minutes. In step 2, we should go out and randomly collect a sample in order to test our hypotheses. We should note our sample size and our level of significance alpha in this step. For this problem, let's allow our alpha value to equal 0.05. In step 3, we should go out and research to find the appropriate test statistic and rejection rule for testing hypotheses of this form. Before beginning our research, we should note the null hypothesis that we are trying to test. In this case, its mu is less than or equal to 12. We should note our sample size, which is n equals 40, and we should note any information that we know about our population. In this case, we know that our population standard deviation is equal to 3.2. For our problem, we are conducting a hypothesis test about a mean. In our case, our n value is 40, which is a large sample case, and sigma is known. Therefore, the boxes presented on these slides have the test statistic and rejection rule that we seek. For our problem, our null hypothesis is that the population mean is less than or equal to 12. That case matches this second box where we have mu is less than or equal to some value mu0. Therefore, we will note the test statistic listed in this box for our problem and the rejection rule listed in this box. In step 4, we simply write down our test statistic, and in step 5, we write down our rejection rule. Here, we should fill in our critical value Z alpha in this rejection rule. Recall our steps for computing this Z alpha value. For an alpha value of 0.05, our steps tell us that we should go to the standard normal table and look for an area 1 minus alpha, or for our case, 1 minus 0.05, which equals 0.95. In step 2, we should go to that standard normal table and look for the area as close as possible to 0.95. If we do this, we will find that the area that we want, 0.95, is exactly in between two corresponding z-scores for the area 0.9495 and 0.9505. Therefore, we use the z-score that is in the middle of these corresponding z-score values. For this problem, our z-score that corresponds to this area is 1.645. Therefore, we plug in 1.645 here for Z alpha when alpha is equal to 0.05. In step 6, we plug in the values from our sample in order to obtain our test statistic value. In this step, we plug in our value of x bar, which is 13.25 for this problem. We plug in our value of mu0, and mu0 is always the value listed in your hypotheses. For our problem, 12 is listed in our hypotheses. Therefore, we plug in 12 for mu0 in our test statistic. We then plug in our population standard deviation value, 3.2, and our n value, which equals 40. If we compute this, we obtain a z test statistic of 2.47. In step 7, we use the value of our test statistic and our rejection rule in order to decide whether we should reject the null hypothesis. Step 5 told us to reject H0 if Z is greater than or equal to 1.645. Since our Z-test statistic was 2.47, we should indeed reject H0. When we reject H0, this means that we have found sufficient evidence to prove that HA is true. In step 8, we should state this in layman's terms. We should state that we have found sufficient evidence to prove that the EMS system is not meeting their response goal. Since our alpha value was 0.05, we can state that we are 95% confident that the EMS system is not meeting their response goal of 12 minutes or less. Example 5. Consider a company that is trying a new and cheaper package design for its product. The average sales for this product are currently $1,500 a month. Suppose they want to prove that sales will decrease as a result of the new, cheaper packaging method. In order to test this claim, they used N equals 36 test stores and computed an average sale of $1,450 with sigma equal to $250. For this example, we should use an alpha value equal to 0.1. Following our hypothesis steps, since we are trying to prove a claim, we should state the claim that we are trying to prove as our alternative hypothesis. In this case, we are trying to prove that the average sales for the product will reduce below $1,500, which means our null hypothesis is that the average sales will be at least $1,500. After stating these hypotheses in words, we should write their corresponding statistical measures. Our null hypothesis is the population mean sales is greater than or equal to $1,500, and our alternative hypothesis is the population mean sales is less than $1,500. In step 2, we should go out and collect a sample in order to test the hypotheses. We randomly selected a sample of N equals 36 test stores. And in this step, in addition to specifying our sample size, we should specify our level of significance alpha, which is equal to 0.1. In step 3, we should go out and research to find the appropriate test statistics and rejection rule for testing a hypothesis of this form. We should note that our null hypothesis is that the mean is greater than or equal to 1,500. We have a large sample with N being 36, and our population standard deviation sigma is known. Here we have the rules for a large sample case with sigma known. Our null hypothesis closely matches this first box, in which we have the population mean value is greater than some number. Our null hypothesis is the population mean is greater than 1,500. Therefore, we should write down the test statistic and the rejection rule listed in this box. In step 4, we simply write down our test statistic. And in step 5, we write down our rejection rule. We should write our critical value in this rejection rule. We should note that we should follow the steps for computing Z alpha, but this rule tells us that we should write negative whatever that Z alpha value is. We should follow our steps with alpha equal to 0.1. Our steps tell us that we should go to the standard normal table and try to find the area as close as possible to 1 minus alpha. In this case, that area is 1 minus 0.1 or 0.9. If we go to the standard normal table, the area section of this table, and try to find the area as close as possible to 0.9, we will find the area 0.8997. This area corresponds to a z-score of 1.28. We should therefore plug 1.28 in for Z alpha in order to have the rejection rule reject H0 if Z is less than or equal to negative 1.28. In step 6, we should use the information collected from the sample that we analyzed and plug those values into our test statistic. Here we plug in 1450 into our test statistic for X bar. We plug in the mu0 value listed in our hypotheses for mu0. In this case, 1500 is listed in our hypotheses. Therefore, we plug in 1500 here in our test statistic. We plug in our standard deviation value and the value of n, and we compute our test statistic to be negative 1.2. In step 7, we should use the value of our test statistic and our rejection rule to determine if we should reject our null hypothesis. Our rule told us to reject H0 if Z is less than or equal to negative 1.28. So we ask ourselves, is our test statistic value less than negative 1.28? In this case, the answer is no. So we cannot reject our null hypothesis. In step 8, we have to write this in layman's terms. The fact that we could not reject our null hypothesis means that we have not found sufficient evidence to prove that the alternative is true, or we have not found sufficient evidence to prove that the average sales for the product with the new and cheaper package design will indeed reduce the sales below $1,500. Now let's get some hands-on practice. Tailbot Inc. implemented a new Healthy Life program which promotes healthy eating and exercise. As a part of the program, employees are provided a 1-year trial membership to a local fitness center. Management at Tailbot are hoping that the new program helps to reduce the average number of sick days per employee annually. The year prior to implementing the program, Tailbot employees had an average of 7.2 sick days. After implementing this program, a sample of 40 employees provides a sample mean of 6.5 days, and a population standard deviation of 2.5 days is known. Set up the null and alternative hypotheses to test if the average number of sick days per employee is different from 7.2. Test this hypothesis using alpha equals 0.01 as your level of significance. You should pause the video at this time and try to complete this problem. Make sure that you follow all 8 of your steps for testing hypotheses. Also, make sure that you have your chart, which lists the appropriate test statistics and rejection rules for testing large sample cases where sigma is known. You should have started by stating your null hypothesis in words, as the mean number of sick days per employee is 7.2, and your alternative should be that the mean number of sick days per employee is not 7.2. You should have stated these using the appropriate statistical measures, as the null hypothesis is the mean is equal to 7.2, and the alternative hypothesis is the population mean is not equal to 7.2. In step 2, we're supposed to go out and randomly select a sample in order to test our hypotheses. For this problem, we selected a sample of n equals 40. So in this step, we should state our sample size, which is n equals 40, and clearly state your level of significance, alpha, which is equal to 0.01. In step 3, we're supposed to go out and research to find the appropriate test statistic and rejection rule for our problem. Before doing this, you should have noted that your null hypothesis is the population mean equals 7.2. You should have stated your sample size as n equals 40 and your population standard deviation as 2.5. You should have next went to your chart for a large sample case with sigma known and looked for a null hypothesis with the population mean being equal to some value. This is listed in the last box on the slide. Therefore, you should list the test statistic and the rejection rule from this box. In step 4, you should have listed this test statistic. And in step 5, you should have listed your rejection rule. You should have stated your z alpha over 2 value in this rejection rule. For alpha equals 0.01, you should have followed the steps outlined for computing z alpha over 2 and obtained a z alpha over 2 value of 2.575. In step 6, you should have plugged in your sample mean value, which is 6.5, the mu0 value, or the number listed in your hypotheses, your population standard deviation, and your n value. In step 7, you should use the value of your test statistic and your rejection rule in order to decide whether you should reject your null hypothesis. Step 5 told us to reject our null hypothesis if the absolute value of z, or our test statistic, exceeds or is greater than or equal to 2.575. Since our test statistic value is negative 1.77 and the absolute value of negative 1.77 is 1.77, and this value does not exceed 2.575, we should not reject our null hypothesis. Stating this in layman's terms, not being able to reject your null hypothesis means that you could not find significant evidence to prove that your alternative hypothesis is true.